Okay guys, let's start with this information about of the first order logic, or in other words, this is going to define like L1 equals, and it's a tuple of 5 where there is a logical constants. Also there is variables as well. We count with the non-logical constants and with the terms. Also there is included the form, and we closed this. It's really important to denote that there are differences between of the zero order logic and the first order logic. An example, the difference is here. In the logical constants, we have one set with the classicals of the zero and the new ones for the first, which is the negation, the implication. Also, we have in this set the conjunction and the disjunction, also the equivalence and the operator equal or assign. As well, we have this which is for all, or in another words, is a universal. And also we have this, which is the existence or existential. This is really important to verify, to make some operations. And also we have the commas and the parentheses in this set, which are really, really important to formulate the logical constants. In the second part, we have the variables. And this is a new one, because in the variables we can define this one set with the n. In this n we are going to have many of them, like 0, 1, 2, and to the infinite. So it's one countable infinite set of variables. So it's countable, and once again, this is our variables. As one example, we can have 1x to the power to the n, and we can have many of those. And this is really important to keep in mind. In the non-logical constants, we have some characters in the zero order, but now in the first order we have some special definition of meaning. We're going to have the union of this n, which start with to the power of 0, and here we have this f, which is meaning the f of n. Sometimes this is going to declare with functions, but sometimes this is going to verify or get to the prepositional or predicate. So also we put here p to the n, and we enclosed this. This is the set of non-logical constants. And to give you one example of this, we can say that this f, it could be a function, or this f also, it can refers to a set of n arguments or over parameters. But also we have another good point when p is going to set proposition parameters, or in p is going to be the n of predicate parameters. So this is really important in the set of the non-logical constants. Let's have another definition, which is this part, the term and the form. If we, let me put this in the correct way. Okay, I got it here. In the set of terms, we have one example given by the inductive definition. If you have one variable union with one function, that is a term. We are going to formulate different formulas or terms by using this definition. Or an example, if we have one function that belongs to this f, and let's say 1 power to the n, and then we can say that n 1, 2 to the infinite is something similar if you have t1 or t2 to and so on belongs also to a term. So there are many ways that we can have a term. So it's really important to check in the slides what is going to be this. And in the case of one form is when we have one predicate. If we have one predicate and this is on the zero, that is a subset of a form. Also, if we have an example 1a that belongs to one form, then the negation of a will belongs also to one form. It's really important to check the slides of the teacher Tamash. This is just the first video for the definitions, and then we are going to explain something of the practical test.